Okay, here's one more example of finding a linear regression line with the TI-83 or 84 calculator. So the first thing you have to do is enter the data. So here we have some randomly selected countries, their per capita gross domestic product, which are measured in thousands of dollars, and the life expectancy in years. So you would probably have the income be the X variable, the explanatory variable, and the life expectancy be the response variable. So stat, edit, I'm going to clear the two lists that are there, highlight the names, hit clear and enter, and then type these in. The Y values. Okay, and you always want to be careful. Make sure you, I see I have a typo there. Make sure you entered the data correctly. Especially if you were taking a test and your answer depended on the numbers you entered, you would want to be very careful, double check, make sure you entered the numbers correctly. But assuming that you have, you can then hit stat, calc, and run number 4. Again, either hit enter if you don't get this menu, or make sure it says X list in L1, Y list in L2, go down to calculate, and you get your line. So this line would be Y equals 0.42X plus 68.72. Okay, so we'll add that to the graph. I'm going to make myself a note here. So let's add that to the graph to check it. Again, I can hit zoom 9 to get a scatter plot for this data. And then Y equals, clear out from the previous problem. And we've got 0.42X plus 68.72. And looks pretty good, going pretty much through the middle of the data there as best as I could eyeball it. Let me point out one extra thing. Some of you may be seeing some extra numbers. Your calculator by default has diagnostics turned off. It's a lot longer to turn them on in the older version of the calculator, but in the newer one you can go into the mode and you go down and it has stat diagnostics off and on. By default they're off. I'm going to turn them on just so you can see. And then if I run it again, we get the same information, plus we get what we call the correlation coefficient, this R squared and R value. Basically, the closer R is to 1 or -1, the more linear the relationship is. It also matches the slope of the line in terms of the sign here. So 0.8 would be a pretty strong relationship. And you can see that in the graph. It's not perfect, but 0.8, it's pretty strong. The line does a pretty good job of fitting through the data. There are points like this that is fairly far off in our window here, but statistically 0.8 is a pretty strong relationship.